So in the time, remember, we talked about this. So the system is already at equilibrium. The system is already at equilibrium, and we have something like this for the sulfur dioxide. For the sulfur dioxide, remember we said it is one of the reactants. So we have the concentration decreases. It decreases till it gets constant. Then for oxygen, it's also the reactant. We say the concentration would also decrease until it becomes constant. Then in the case of the sulfur trioxide is a reactant, so it's the one that's being formed. So we say that the concentration will increase until it becomes constant. So the system is already at equilibrium. Take note, the system is already at equilibrium. So we want to see what happens if first of all, what we're going to do, I'm going to increase the concentration of this. Remember that this is happening in a closed system. It's happening in a closed system. Remember we said in a closed system, nothing goes in and nothing comes out. So if, for example, I use a syringe in that closed system, it's happening in a closed system. I use a syringe. I introduce sulfur dioxide. I use a syringe. This is a closed system. I pump in sulfur dioxide. And remember sulfur dioxide, immediately I pump in sulfur dioxide. So in other words, we are saying the disturbance here is increase in sulfur, the concentration of sulfur dioxide. That's the disturbance here. We are introducing the increase in concentration of sulfur dioxide. So in other words, when that happens, you will see here, you will see a sharp increase, This is my interference now. This is my disturbance. I'm the one disturbing the system now. There's a sharp increase. So anytime you see a sharp increase here, you will know that I've introduced sulfur dioxide. Remember, this one remains the oxygen, and this one remains the sulfur trioxide. So this is the disturbance. The system is already in equilibrium, and that this system is disturbed. I've disturbed the system by adding more sulfur dioxide. So we want to see, according to